Section 16.6, Fission and Fusion. So the big thing, I just want you to know the difference between fission and fusion. So fission is when we take a large radioisotope and we split it up. So for instance, here's uranium-235. This is what goes on in nuclear reactors. We shoot a neutron at it, right? That neutron makes it unstable, and then it splits up. Here it splits up into a krypton and a barium, and then it gives off 3 more neutrons. Now, those neutrons can go on to hit more uranium. Now, this causes a release of energy because of E equals mc squared. This shows the relationship between mass and energy, okay, and how mass can be converted to energy. The chain reaction, as I mentioned, here you go. Here's uranium being hit once, right? Gives off 3 neutrons. Those neutrons can go and hit 3 more uranium, which can give off more neutrons, and it goes on. Now, the way that we stop that is we typically use carbon rods, and those carbon rods will absorb the neutrons, and then if we absorb enough, we can make those carbon rods go away. Right? So those are the rods. Now, fusion, that's the holy grail of science right there. So fusion is when you take smaller nuclei and combine them to make a larger nuclei, and you get a ton of energy. This is what goes on in the sun. And if we can ever get a fusion reaction that occurs at lower temperatures, like let's say a tabletop fusion reactor, a room temperature fusion reactor, then energy woes are gone. All right? We can cause fusion at very, very high temperatures. Why does it have to be very, very high temperatures? Because we spin these small particles around so fast and make them collide. How do you get them to spin fast? Well, we're going to heat them up.